That's the difference. Okay, so let's begin. This is notes 2.9. 2.9. And it's dealing with reciprocal functions. Which you actually have done already. We already done them. You actually had a question about a question like this on the first test already. But we're just going to dive a little bit deeper this time. Okay? So reciprocal, in simple words, that means there's an x in the bottom. I shouldn't put this on video because I'll get in trouble for saying about denominator. This is denominator. But that's what I'm referring to, right? The denominator. So we have an x in the denominator. Okay, so let's get the symbols out first. So f of x equals a times x to the negative n. Okay. That's the same exact thing, so that's the same thing. A is just the number, and n is just the number. So just picture any number in there. Okay? But that's the same exact thing as f of x a over x to the n. Okay, so that's what we mean by x in the denominator. Yeah. So the denominator is the bottom, the top one is the numerator. Okay, real quick, super fast mini lesson. I've taught about this before, but just again to kind of refresh your mind. If you have a negative power, like a -2, for example. Okay, the way I teach that, and you've been learning about this in freshman year, but I teach this negative powers as being unhappy. Okay, and they're unhappy where they're located, so they want to be happy. And there's only two places to go: numerator or denominator, top or bottom. So this one, it's really, like if I break it down, it's really over 1, right? So right now it's really in the numerator. So the only other place for it to go is the denominator. So if I move it down, now it's a +2, which means positive mood, happy mood. Negative mood, sad mood. Okay. One thing students kind of mess up here is they think we're switching, like we're switching the top with the bottom, and that's not what we're doing. Okay, like let me do some colors here. Like if this was the purple, that's still the purple one, and if this one's the red one, that's the red one. So I didn't switch numbers because it's the x, just the x. I'll give you an example with the numbers so that it's easier to see. Let's say I had let's say I had a 5 over 3 to the -4. It'll be easier for you to see it on here. So the 5 and the 3 stay right where they're at. You don't touch them because they actually have a positive. Actually, it's all connected. All this stuff is good. They have a positive power. It's a power of 1. So positive is happy, so that's why they stay. Okay. But the fourth one is sad up there. He's in a negative mood, so it comes down to the bottom. Now it's positive, now it's happy. But the numbers stay where they're at. Okay. Same exact thing for if it's at the bottom to begin with. So all these are just little examples. Let's say you had 1x to the -3 over x to the -3. That means it's unhappy in the denominator and it wants to be in the numerator, right? So we bring it up to the numerator and now it becomes happy. Okay, again, it's still over 1, but we don't really need that 1 there. Does that make sense, guys? You're following me? Okay. Let me give you like a messy, or not messy, but just an example with a lot of stuff going on so you see how. Okay, so let's say we had -2. This is the last one I'll do. This -3, 5. These are the kinds they put a lot of, always on the STAR test. There's one of those on the TSI. They put that question to see if you know what they, is to see if you know the rules. Okay, and this is just the division rule. It's not, I'm not mixing other rules, but here's how. When I teach this, in algebra 1, algebra 2, I just tell them to mark it out. Like, okay, that one stays because there's no power. Okay, just one at a time. X, so unhappy. So we move it so it becomes happy. This one is happy because it's already positive, so it stays. If it's happy, you don't move it. The 5 is happy. The Y is unhappy at the bottom, so it wants to go to the top. Now it's happy. The W is unhappy, so it goes to the top. And it becomes happy. So now everybody's happy. Yeah, that's the point. You want to make everybody happy. Understand? Easy, right? It's easy. Okay. Okay, that's just kind of a little mini lesson. Okay, so let's kind of, this is kind of, just so you kind of refresh on negative powers, how they work. So a little mini lesson there. Okay, now let's go back to reciprocal functions. Okay. So reciprocal functions, the good thing is they break down again into even and odd. So we're going to follow that pattern as before, even and odd functions. Okay. Before I continue, let's connect it to what's fresh on your mind. So what does the even degree look like? What letter? The W. And then the odd one on the degree looks like the S. Okay, I want to switch our lingo a little bit so that now these will also apply to this. So it fits these graphs because these ones don't look like W's and they don't look like S's. Okay, let me first write the equations down. Let's do f of x equal x to the negative 2, that's an even. And then this one we'll do f of x equal x to the negative 3. Odd, even, okay, that's what I mean. It's not a parabola and it's not the S because they're negative. So this one's really one unhappy, happy. It's really a fraction. Right? And then this one's really a fraction too. So that's why it's not the parabola. Okay, it's not like a, you might think, oh, it's upside down parabola or something like that. That's not the case. Okay, what I want you to know, well, let's graph it. Let me show you what it looks like. Here's what it looks like. Okay, there's actually asymptote here, and there's an asymptote here. This is called a horizontal asymptote, and it has a vertical asymptote. We're going to talk more about those, but I just want to go ahead and get the elephant in the room out of the way. Like that's one of the biggest differences between these and the ones that you've done in the past. Okay, they have asymptotes. So they both have them. Okay. So remember, I'm going to talk more about what they mean, but you can't, it's like a wall and they can't touch it. Okay, so when I graph these, so I'm going to go ahead and graph them. It comes like this, it gets really close to 0, but it doesn't touch it, and then it goes up. And it gets really close to that wall, but it never touches. And then the same thing on this side. It gets really close, but never touches, then it comes down really close and never touches. Okay. I'm going to tell you, this one looks like this. Again, it gets really close to the walls, but they never touch. Can you guys tell how like they're the same thing kind of? It's just the left side is flipped on the odd one?
Yeah.
Right? Yeah. Okay, honestly, I'm going to tell you the truth, okay? Like me, as a teacher, I forget what these look like over the summer break. I don't remember. But here's how I know to remember. When you plug in like a negative 2 for the x, do you get a positive answer or a negative answer if you square it? Positive, right? Because a negative times a negative is a positive. So when I plug in negative x's, my y's are positive. When I plug in positive x's, my y's are positive. Over here, though, when I plug in positive numbers into cubic, positive y's. But what's negative 2 cubed? Positive or negative? You're going to ignore it. Negative, so that's why it goes to the bottom. That's how I remember over time, just in case you get stuck. Okay, now you're like, how am I supposed to remember that? Remember how we said look like a W, look like a S? I want to fix not fix it, but adapt it to this. Where are both my left arm and right arm pointing in the W? Up. Left arm, right arm, up. Okay, so they're still both pointing up. Okay. Here, my left arm is pointing down. My right arm is pointing up on my S shape, right? Same thing here. Look, the right one is pointing up. The left arm is pointing down. So it still fits my odd and even degree. It's just the shape's a little bit different. Osvaldo, alzate el teléfono. Is that okay? That make sense? Okay. What else could we tell you? Okay, there's more info, but okay. Let me see. I guess we can add this right here. Vertical asymptote. No, before I move on, well, let's answer some important questions. Instead of breaking all the questions down, let's just answer like the important ones for these. What would be the x-intercept and y-intercept? None. Why none? Because there's the walls right there, right? It never touches. There's the asymptote. So just by definition, if it can't touch the x-axis or the y-axis, then none. I'm not going to answer like the questions that you do know. Okay, I'm going to answer the ones that you might get stuck on. For example, symmetry. We haven't talked about that recently, but we have in the past. Anybody remember what kind of symmetry this is? Huh? That was reflection over what? Y-axis. So we call that y-axis symmetry. Y-axis, let me do a different color here. Y-axis. Or, I know we use even and odd a lot, but it is called even symmetry as well. Okay. What kind of symmetry does this one have? Point. Okay, so I don't know if you remember, but that's the one where you flip your paper. Hey, man. If you flip it upside down, it's at the same shape. But you might do that on your desk real quick. Like, flip it upside down, and you'll see it's the same exact shape. Same exact shape. Okay, that's called point. Point symmetry or odd symmetry, which I think makes perfect sense because it's an odd function, odd symmetry. Even function, even symmetry, right? It's the same. What else is unique about this? Okay, so the domain and range. You might struggle a little bit answering the domain and range. Let's do the domain on this one. What's the most left? This will go. This one. Negative infinity. All the way into what number? No. Zero, right? Because that's where the wall is, right? I can't touch the wall. So I'm walking, but there's a wall. So I have to jump over this wall. That zero, since it's the domain, is not the y zero. This is the x zero, just so you know the difference. Okay? I jump over the wall, so little u. Okay, and then I start back at zero and keep on walking forever. Okay, so to infinity. There's the domain. Okay, let's do the range for this one. Or no, domain. What's the domain? How far left can this one go? Negative infinity as well, right? All the way until zero. That's where the wall is again. Jump over the wall, zero to infinity. Remember, this zero is not because of the y. It's because of the x. The wall on the x. Does that make sense to everybody? Yeah. Why we're jumping over that? Yes? Okay. Range. What's the lowest we can go on this roller coaster ride?
0.
0, okay, but we can't touch 0 because there's a wall on the floor, right? This is the y0, not the x0. It's confusing because they're both 0 right there, but this one's because of the y. And then how high can this go? Infinity. And that's it. You're not jumping over anything on this one. Okay. Range on this one, I can go down forever. Up until where? 0, right? That's where there's a wall right here. So this is the y0, not the x0. Jump over the 0, and then I can go up forever. Does that make sense? Okay. Now I should write increasing, decreasing down here, but I'm gonna write it on the graph. Okay, is this part increasing or decreasing? Increasing. How should we write? We just put E and C. Is that okay? It's increasing. Okay. What about this part right here? Decreasing. So decreasing. Now, to me, when I see E and C, like I know what I'm talking about. If you don't know what E, like write it out. Increasing, decreasing. It's your notes. They have to make sense to you. This one's harder. What is this one doing right here?
Decreasing.
Decreasing. It's going down. From left to right, it's going down. So decreasing. What is this one doing? Decreasing as well. Okay, so it's always decreasing. And we would write it again with the x, always, okay, with the x. So it'd be the same as our domain. Okay. What other important? End behavior, I think you guys are good with it. Yeah, I think that's it for the parts. Not too bad, right? Okay. I do want to introduce you guys. I don't know if I should wait till tomorrow to do this. I'll give you a brief introduction. Tomorrow we're going to dive more in depth, but I'll give you a brief introduction to this part. That's right, part 2, discontinuities. We're going to dive more deeper tomorrow, okay? But just real quick, what do we mean by discontinuity? Again, don't show this to another math teacher, but it means f of x. So whatever graph you're talking about, okay, can't touch. Whatever it can't touch, that's what we call discontinuity. Okay? It doesn't exist. It's discontinuous. Like it's like a roller coaster, and if there's a piece missing, it would fall through that piece. It's discontinuous right there. Okay? So I want to kind of show you a brief introduction to this. So kind of in the middle of your paper, draw this. Draw like an asymptote a little bit above the x-axis, and then draw another asymptote, a vertical one, a little bit to the right. I'll give you the first key to graphing these is the asymptotes. Always do the asymptotes first, and then you do the other part. Okay. Okay. So let's draw this one here. And then this one right here, but I'm gonna put a hole. We have talked about holes in the past, and we exaggerate them. We put them really big, so like they stand out. Okay. So here's what discontinuities are. Okay, so asymptotes. So that one and that one. Okay. Those are discontinuities because you can't touch them. Okay. More precisely, and again, we'll dive more deeper tomorrow, but these are called infinite discontinuities. Which again makes perfect sense because it's infinitely long, so you can never touch it, no matter, right? No matter how high or low you go, it's always there. So it's infinitely long. Okay. This right here is called a hole. It's also a discontinuity. It's called a removable And I'm ashamed to say it, but I don't remember why it's called a root rule. When I was writing the notes, I couldn't remember. I have to look it up. It doesn't make sense, but that's what it's called. And you guys know another one. I'm not going to draw it, but remember when we would do piecewise functions and you had to jump from one hole to another? That was called the jump discontinuity. So there's other types, but right now we're going to focus on those two. And then right now, I want to focus on this one. Okay. This is called the vertical asymptote. Again, common sense because it's vertical. But horizontal asymptotes, there's a reason why they come to be, okay? But right now, we'll save that for later. Right now, we're going to learn where do the vertical asymptotes come from? So where do they come from? That's too long on a title. I should have put how to find instead. But this is where they come from. Okay, they come from the fact that when you have a fraction with a numerator and a denominator. Okay. I always used to get this confused. Which one? And don't write this down, but which one can't you do? Like I always used to mess these up. One of those you can't. One of those, the answer is 0.
You can't have 0.
Yeah, the answer to this one's 0. This one you can't do. You'll get an error. Interesting, maybe to me it's interesting. There's some math equations that are like super complex, like mathematicians that like, that's how they know that there's no solution to it because at some point it's dividing by 0. Anyways, based from that fact, that's where this comes from. The denominator cannot equal 0. Because if it does, then that happens. And we don't want that to happen. Okay, so that's where vertical asymptotes come from. Okay, so if I show an example, it's going to make more sense. So let me show you a quick example. What is the equation of the vertical asymptote? Sounds like a super hard problem, but it's not. Let's say you had f of x equals 1 over x minus 2. Okay, so remember the denominator cannot equal 0. So the bottom, this is the denominator. I'm going to set it equal to 0. I don't want it to equal 0, but I'm going to try to find out one number is going to make it equal 0. Well, we just solved that simple equation. We just add 2 to both sides. X equals 2. But that's not a root. That's not an x-intercept. That's the number that if you plug it here, what will happen if you plug 2 right here? 2 minus 2 is? 0. 0 on the bottom causes breakdown, okay? So at x equals, so my equation is that. Okay, now let me show you a visual. Okay, so this looks like this. Okay, at x equals 2, 1, 2. Okay, we have a vertical asymptote. That's what that means. Okay, this is odd. Now we're going to practice our graphing. Okay, the odd or even function. It's the power. So, right, what power is on the x? 1. 1 is odd. Okay, so it's odd. Odd means left arm is going to point down, right arm is going to point up. So instead of saying the S shape, that's really okay. So the left arm point down, down. The right arm is going to point up. This is the right arm. This is the left arm. Okay? Okay. And of course, these are all, I'm just giving you like the Lego pieces, and then we put them all together. Okay. Part 3, I don't know, 4, I don't know. Let's do transformations now. Most of this week will be focused on these equations, from what I gathered. Okay, so if I give you f of x equal negative 2x minus 4 plus 3. Even without me like explicitly teaching you, you guys can probably figure most of this out, or if not all of it. What does the 3 do?
It goes up and
Up. So up 3. What does the minus 4 do? Right, just like before, okay? So that's why I always say, if you learn these, they're the same all year. Okay. What does that negative do? Flips, reflects over the x, which is like a flip. The only one you might be in a little bit of doubt is the 2. That's your A, the vertical stretch. So on a simple equation, because these are a little more complicated, it would look like this. That's the equivalent of that on an easy one. Okay. That's the same thing. Okay. Is this the only thing, if you notice, who's the only that's like in a different spot? The x minus 2. The 2 kind of looks like it is, right? This is at the top, but if I were to move this here, it's still identical to that. Okay. So everything else is the same. Okay, let's sketch this. Okay. So now we're going to practice this. So the point of this is that I give you this, we sketch and we answer all the questions. We can answer all the questions till we can sketch good. Okay, so let's practice our sketching. Let me break this up to examples.